So I see Pascal has joined us, so I'm going to go back to presenter number 2, Maria,
Thank you.
and have Pascal introduce her. Go ahead.
Well, it's my pleasure to introduce Maria Soldatova. I'm a planetary scientist with the Mars Institute, the SETI Institute. I'm based at NASA Ames. And the topic for Maria's internship is to help us design a helicopter for future human explorers on Titan, the moon of Saturn. And I'll let Maria tell you why that's even possible or even desirable.
So take it away, Maria.
Should I share my slides or no?
Yeah, it's up to you if you'd like to control your slides, or I can share them and click when you tell me to click. It's up to you.
Okay, then I will do that. Okay. Okay, cool. Are you guys able to see my screen or no?
Yeah. There we go. It's loading.
Okay. And now I just have to. I'm gonna hope this is okay. Okay, so my project was about designing a human helicopter for Titan. And I was working with Dr. Pascal Lee. And this is just a preliminary design because there are many changes that still need to be made to accommodate the astronauts and the conditions on Titan. Okay, so
sorry, I don't want to interrupt you. We're still seeing your PowerPoint window, so when you advance the slide, it didn't advance for us.
Okay.
If you're having issues, I'm happy to share, but if you want to try again.
Yeah, would you be able to share them?
Mm-hmm.
I think it might just be something for mine.
Maybe the slide didn't work because of the licensing issue was flagged. So presumably Ariana has a license and it worked better for her.
This happens plenty of times with Zoom, don't worry. And sometimes you have to exit and come back in. I've been doing it since COVID started. So don't worry.
Should I share her slides?
Ariana, do you have them?
I do have them.
Okay, why don't you go ahead and share them? Because I think it's not going to work for her because she doesn't have a license.
Okay, here we go. Is this full screen for everyone?
Yep.
Almost. There we go. Okay, that looks much better.
Okay, great. So Titan is the largest moon of Saturn. It is 6% larger than Mercury and 50% larger than our moon. So that's, just imagine our moon and then 1.5 times that, and that is Titan. Okay. Next slide.
Does
Titan,
anybody see slides? Because I don't see slides right now.
Oh yeah, I'm seeing them just fine.
Ah, okay. How does that work then?
I don't know.
Okay, yeah, on Ariana's screen, yeah, at the top. Okay, got you. Sorry, go ahead.
Titan is a moon that has an atmosphere, which is kind of rare because not a lot of moons have atmospheres. And like Earth's atmosphere, it is made mostly of nitrogen, so very high 90%. The atmosphere is 1.4 times thicker than the Earth, and the surface is invisible through visible light just because the upper atmosphere has, it's very hazy and it's very difficult to see just because it's of how the fog and I guess the coloring of it as well. So, Titan was revealed to have land and lakes, and the temperature is extremely low, so that's negative 291 degrees Fahrenheit. The land is made of water ice, specifically water, where there could be some other liquids that have frozen over into ice, but it's mostly made of water ice. And there are lakes of liquid ethane and methane. The gravity is less than Earth's and our moon's, and the low gravity combined with the thick atmosphere makes it much easier to fly on Titan than it does on the Earth, than it is on Earth. Okay. And here we can see a radar map of Titan based on Cassini, NASA's Cassini. What we can see, like the dark areas, are just like smooth surfaces. So most of it would be lakes, but because it's not very like clear, there are some others just smooth surfaces basically. And the lighter stuff is rougher surfaces. Yeah, and so here we can see a picture of the upper atmosphere, which is like the top part, and the lower part is the lower atmosphere, where we can already see some of Titan's terrain. And this was taken by the European Space Agency, is Huygens. And this just gives us a clear picture of, I guess, what Titan looks like. Next. And this is an even better view of the terrain on Titan, again taken by the ESA's Huygens probe. Okay. And here, these are just a bit more details on the surface conditions on Titan on the left, and these pictures in the middle and on the right. So the pictures in the middle are like upper atmosphere, then it just as Huygens descends, we can see more of Titan's terrain and what it looked like. And especially on the right, I want to bring attention that these these like rocks, kind of the things that looks like rocks, they are water ice. They're water ice rocks. So it's not like stone. This is just frozen over ice that is scattered across the surface. And yeah. Next. Myself, as well as Dr. Pascal Lee, this is an interesting project, especially because NASA is launching the Dragonfly rotorcraft set for Titan, which will launch in 2028, and it will arrive in 2034, which means there is a 6-year travel period from the Earth to Titan. So it is kind of far. And because of how cold and like the gases that are on Titan, the astronauts will need a spacesuit. It doesn't have to be pressurized because the atmosphere is thicker, but it will need to provide oxygen and heating because of how cold it is on Titan and because of the composition of the atmosphere. And here we can see what that spacesuit will look like. Okay, and so this is what I designed. This is the helicopter that, I designed. So these floats are specifically made for landing on Titan's surface. Because of the amount of lakes and smooth surfaces there are on Titan, me and Dr. Pascal Lee believe that floats would be the much better landing option for a helicopter, as to like make sure that they're like in case we land in like mud or something similar, the helicopter will still be able to lift off and not get stuck under that mud. And here we can also see that the main rotors as well as the tail rotor is shorter because the atmosphere is thicker. So there will the RPM will be less. There will be less RPM as opposed to Earth, because thicker atmosphere is equal to less rotations per minute to be able to lift off. You can see these paddles right under the main rotor. These will stabilize the main rotor. These are specifically used to stabilize the main rotor, and many helicopters on Earth have them, again, as a stabilizing tool. And this tail boom is a bit shorter than helicopters on Earth because the tail rotor has less RPM. So less RPM shorter tail boom, and that's how we get there. Yeah. And the hull as well as the floats are all kind of designed in a cylinder fashion, just because of the composition of Titan's surface, whether it's muds or lakes. So the astronauts are able to get out, get in, and the helicopter is able to lift off more easily. Next. Okay. So these seats, as we saw in the spacesuit, they will have to be carrying around a backpack for that heating and oxygen to be so they're able to breathe and are able to stay warm. These seats reflect that with being deeper than the regular seat is usually. And there will be storage behind the seats or underneath the seats that is not yet completed, so it's not yet shown. But that's where the astronauts can store researching equipment or anything that they need to be able to complete their mission on Titan. The height, as well as the angle of the floats, is specifically for the astronauts to have a comfortable descent and ascent to get into this helicopter and get out of it. So nothing is limiting for them, and it's very easy peasy, kind of. Next slide. Yeah, and so this power plant will be the how this helicopter will be powered. Me and Dr. Pascali were thinking of battery, especially because of how cold Titan is. So many modern things just will not be able to last on there because most modern technologies don't really respond well to cold. Yeah, and again, storage will be behind or under the seats for easy access of the astronauts and their research. Yeah. And here I want to talk a little bit about just the cabin of this helicopter. As we can see, the collective, those are kind of like emergency brakes in a car. So in case something goes wrong, each astronaut can pull their own collective, and this will allow them to emergency stop the rotors, the tail rotor. And the cyclic is used to control the lift and direction of the helicopter. So each astronaut would hold one handle, and this design is called the T-bar. This allows for each astronaut to control their own. And if, let's say, the astronaut on the right can't control for some reason, then the astronaut on the left will have the same exact control and view that the astronaut on the right has, which is very nice. It's very independent. It just allows for, I guess, more free hands. And this instrument panel, as I mentioned, is analog dials because modern technology will not survive, has a very little chance of surviving the cold on Titan. And these pedals are individual, so each astronaut has their own pedals to, again, be able to control their own, to be able to control the helicopter on their own. Yeah. And this is just a picture of the helicopter with the astronauts that, I guess this picture is actually painted by Dr. Lee's previous intern that designed these spacesuits. But here we can see kind of the surface on Titan with these astronauts and the helicopter in the back. And the main rotors are at an angle lower just because it's standing. It's like sitting right now. Yeah. Oh, and this is the final picture, and it shows my helicopter in flight. And this is on Saturn, where hopefully this will be, it breaks the atmosphere, breaks the upper atmosphere, and we can see Titan. And this was actually drawn by Dr. Pascal Lee. Yeah, and I also want to thank the entire program, entire program, and Dr. Pascal Lee for allowing me to design this by myself and do this internship and get this experience.
Awesome. Thanks, Maria. Let's give a round of applause for her incredible work. Beautiful images and great slide design throughout. I want to commend you on that. Lynn, I think your internet has finally given out on us. I sent you a message that we can't quite hear you. Wendy shared a question for you in the chat. Could this helicopter work with robots instead of humans and send data back to Earth, since it would take humans a very long time to get there and back?
So this helicopter was designed with humans in mind. I am not sure about robots. That is not something that I have thought of, but yeah.
And Lynn asked if you drew the helicopter or used CAD or maybe another software.
I used CAD. Yeah, I used CAD modeling.
Cool. All right, well, thanks, Maria. I'm going to move us along for the sake of time, but if anyone has another question, you can pop that in the chat for her. Thank you again for great work.